Hello everybody, getting ready to do lesson 4.1 part 2 today, Algebra 2 Math. Part 3 is available here. And 4.1 part 2, here is your standard, and we're going to graph exponential growth functions. We have a 28-point skill sheet today for your classwork. If you need classwork sheets, email me for those. And we have no notes today. So page 1 on your classwork sheet, the graph of function y equals ab to the x is a vertical stretch or shrink of the graph of y equals b to the x. The y-intercept of the graph of y equals ab to the x occurs at 0a rather than 0. So we have a little bit of a different shape of our graph there. Here is some smartboard markings. I think they'll help here. Example 2, graph y equals ab to the x for b greater than 1. Graph function, so y equals 1/2 times 4 to the x. Here's an example here of ab to the x. So we're going to plot 0, 1/2 and 1, 2. And then from there we can probably sketch the rest of it. So y, left to right, draw a curve that begins just above the y-axis. So here's a y equals 1/2 times 4 to the x. When x equals 0, y equals 1/2, which is right there. And then when x equals 1, y equals 2. That's this plot here for that. We know the general shape is going to be like an exponential like that. So it passes through the 2 points and moves up to the right. Yeah, we know that. Do we know anything about anything else? Well, let's graph y equals ab to the x for b greater than 1. So y equals negative, the negative of 5/2 to the x power. So plot 0, -1, and 1, -5/2. You can put this into your calculator and also see a table of values. Here's the general shape of the graph here. So when x equals 0, y would equal -1. And then when x equals, this is x, y, I guess. I mean, that's kind of a y there. When x equals 0, y equals -1. And then when x equals -1, we have the negative of 2/5. That's not this here. But this is what I discerned here as the shape of the. Let's look at it. Again, these are smartboard markings here from left to right. Draw a curve, pass through the 2 points. So right here was when x equals 0 in this function here. When x equals 0, this is -1 here. When x equals 0, then when x equals 1 here, y equals -5/2, which would be this plot here. And then you got the general idea here of how this exponential is going to go. You could stick that in your calculator and also check yourself on that as well. Okay, so here is our guided practice here. Since this is yours, this isn't on your classwork sheet, so look when you can. We're going to go into our guided practice here. Graph the function, state the domain and range. So we got state domain and range here. F of x equals 5 times 2 to the x. So in that situation, we have when x equals 0, y equals 5, which would be here. So here's your y-intercept here. And see when x, you could go into your calculator and find go into table to find other plots here for that. But this is the important one here. We know the general shape of the graph is going to be like this because it is an exponential. And then the range is y is greater than 0. Your horizontal asymptote would be your x-axis here. And then the domain would be all real numbers. Theoretically, this graph will go forever in the positive direction on x and to the negative direction as well. So there's your range and domain of this. So page 7 on your classwork sheet, to graph a function of the form y equals ab to the x minus h plus k, begin by sketching the graph y equals ab to the x Then translate the graph horizontally, h units. So this is our horizontal translation. And then vertically, k units. This is our vertical translation. Okay, getting into page 8 of our class worksheet here. We're going to graph y equals ab to the x minus h plus k for b greater than 1. We have a situation here, 4 times 2, x to the minus 1 minus 3, state the domain and range. Here is our parent here, and here's our translation here. Begin by sketching the graph y equals 4 times 2 to the x. That would be our parent here, which passes through 0, 4, and 1, 8. So it goes through here and here. So those are 2 points there that we can translate from. Then translate the graph right 1 unit and down 3. So it's right 1 and then down 3 here. Here's our translations for this graph here. So we translate 1 to the right, down 3, 1 to the right, down 3. And we have our 2 points here that we can sketch through. And then for this one here, when x equals 0, 4 times 2 to the negative 1 minus 3, what would that be? I don't know. Go on your table, students. Okay, again, here's your parent and your translated graph. The graph's asymptote is the line y equals negative 3, which should be down here. Here's your horizontal asymptote. The domain is all reals. This will be your domain is all reals. And the range is y is greater than negative 3. So this will be your range up here. Okay, into our guided practice, graph functions, state, domain, and range. We're going to do this one here. Students, this is your independent practice down here. I got some smartboard notes here. Look when you can. So into our guided practice, graph functions, state, domain, and range. So here is our graph here. So we're translating from this to the left. Let's see what we got. Oh yeah, to the left 2 and then down 4. Here's our parent function here. Then we're going to translate to the left 2 and then down 4 to get our 2 points on this function here. And this is what it looks like here once you do your translations. Domain is all reals. So our domain will be all reals, and then our y values will be y will be greater than negative 4. Y equals negative 4 will be your horizontal asymptote down here. And domain's all reals, and then range is y is greater than negative 4. That would be our range for that. And then here is the function here. For this is the parent function here, y equals 5 times 3 to the x power. And then here is the actual function that we wanted to graph here. This is how it would look on a graphing calculator here to check yourself. You could go into table and find these values as well. And that is 4.1 part 2. Part 3 is available here at this email as well as all of your course materials. Email me for that. Thank you very much.